Purple is the amount of time spent in rendering or displaying the content to the screen. But you can see that each of these 5 sites have very different patterns in where the time is spent. If you take that content and you average it together, you can see that this is kind of the average across all of those 5 news sites. And the question a lot of people get is, well, those are news sites. They're relatively static content with a little script. What about AJAX sites, right? These rich sites that we as developers build. And so we went and looked at the data for some of the top AJAX sites in the world. Gmail, Hotmail, Google Docs and spreadsheets, the Office web applications. And what we did was we averaged those together, and we see a pie chart that looks something similar to this. Now, the proportions change, but you'll see that performance is still greatly impacted by all of the subsystems. Here are the subsystems that we're going to look at today. And in this slide, there's actually 11 of them, starting with networking. And I'm going to walk you through each of these 11 subsystems. I'm going to give you an idea of what the subsystems are and what they do. And I'm going to show you some best practices for optimizing your content in those subsystems. And these are the 20 best practices that we would strongly encourage you to start leveraging today to improve performance. We'll start with networking. The first best practice is to compress network traffic. Here you see a very typical HTTP request and response. And you'll notice, though, that on the left, we've specified that we accept the gzip encoding. And on the right, the response sends it back to us as gzipped content. This is standard technology that all servers support today. And you'd be surprised at how many customers or web developers forget to set the right zipped content on their sites and are actually losing from compressing their network traffic. Now, there's one exception to this best practice, which is that you should not compress images. Images are already compressed inside the file format itself. And by actually compressing it again through gzip or another compression technology, what ends up happening is, in best case, you'll end up with an image that's the same size. In worst case, you'll end up with an image that's actually larger. And you'll force the browser, all browsers, to spend a bunch of time decompressing the image when it arrives down. So the best practice is to compress network traffic, except for images. The second best practice is really to provide cacheable content. How many of you provide cacheable content today across your web properties? It's a surprisingly small number of hands. And when I talk with customers, many times customers who think that they're providing cacheable content, when we go in and look, in many cases they're not caching as much as they need, and that's often because they're a little bit worried about updating content on the server or the impacts of caching. And here you'll see on the left we have our first request and our first response. And in our response, it specifies that the content is not going to expire for some period of time. So in this case, the content's not going to expire until this Friday. So by doing this, the browser is able to cache the content and will pull these images or content out of the cache. In this case, it's an image, rather than requesting it again from the network. And here you can see kind of the second request, and we don't have to pull it. The next best practice is conditional requests. And conditional requests allow you to specify content that may be modified from a certain date. So in this case, the request goes out, and it says, if the content has been modified since the last time I downloaded the content, send down new content. But if it hasn't, go ahead and pull from the cache. And in the response, it'll return when that content was last modified so that the browser knows what to do. Now, in addition to kind of compressing the content, you can actually use techniques to compress inside the content itself. So in this case, the best practice is really to minify your JavaScript. On the left, we have our original JavaScript source code for one of the routines that's actually on the test drive website that we just released. And if we were to minify that, and what the minification process does is it goes through, it removes all the spaces, it takes the variable names and collapses them down to single characters. It actually sometimes compresses the call patterns that are used. By minifying that JavaScript, we can actually decrease the amount of script by up to 75%. So your resulting script in many real-world scenarios can be about 25% of your original script size. And as JavaScript becomes more and more important and is more broadly used through the rich frameworks that are out there, the minification process becomes more important. The last best practice that I wanted to share, and this is one that really feels like common sense, but you'd be surprised at how often people forget to do this or make this mistake, and that is not to scale images. Scaling images has, in this case, let me show you what I mean. So we have a logo that's 500 pixels by 400 pixels wide, but when we go to use it, we're only using it 50 pixels wide by 40 pixels tall. Not scaling images, starting with kind of an image of the actual size that's going to be used allows you to send less content over the wire, and it also requires less CPU time for the browser once the image has been downloaded. So in this case, we could use Photoshop or another image program and start with a 50 by 40 image. Of the news sites that I mentioned, 3 of the 5 news sites on their homepage are actually scaling images. And the last network optimization, which is really an extension of scaling images, is using image sprites. Now, if you remember, one of the news sites was using about 120 different images. And that's because every little icon on their page was a separate image. This comes with overhead in the size of the image file. It also increases the number of network requests that occur. By using an image sprite, and for those of you who are not familiar with image sprites, it's really a technique to take multiple images and put them into the same image. By using an image sprite, you're decreasing the total number of bytes going over the wire. You're also decreasing the total number of network requests. You're allowing the images to get to the browser sooner. And in doing so, you're improving the performance of your overall page. Once that large image has been downloaded, the technique you can use is using CSS techniques and divs. You can actually use that same image and move it around on the page to position it in the correct location to just show the individual image that you need. I wanted to show just one Internet Explorer 9 feature which we've added this release, which is the new network tools, which help you really understand and improve networking performance for your sites. For those, how many of you had a chance to download the platform preview release of Internet Explorer 9? Just a couple of hands. The platform preview release, and as the tools that you saw in the keynote today, the developer tools are included in the platform preview release, and they include our new networking tool, which allows you to look at all your network traffic and even go into the very specific details around the headers, requests, and responses, and how that content is being used, how it's being cached. So let's move on to the second browser subsystem, which is the HTML parsing subsystem. When the initial request goes out and the HTML comes down, this is the first piece of the browser that really comes into play with regard to performance. The browser starts parsing the HTML, and as it encounters files that need to be downloaded, it's going to go fire off those downloads. There's a few things that can block the browser from downloading additional content or from parsing. This is less true in Internet Explorer 8 and some of the modern browsers that you might be targeting. But this is a concern for some of the older browsers that are still broadly used across the internet. One of the things that can actually block parsing and impact is inline JavaScript. So in this case, you'll see that we have some inline JavaScript in the head. With some of these older browsers, what happens is when they encounter the JavaScript, they actually have to go and execute that JavaScript before they can move on. And that's because the JavaScript could actually be doing something like a document.write and manipulating the remainder of the HTML content. So it can't finish parsing the HTML